So yeah, hello everyone. So today we are going to discuss the contest. We are going to hold a post-contest discussion for the Codechef contest that was held. So let's start. We are going to discuss 4 questions for today, diff to 4 questions, in the order they came in the contest. So let's start with the first one. So that's the first question. The name of the question is Chef loves pizza, Chef loves halves. So chef has a unique way of cutting round pizzas. He starts by cutting the pizza in half, then into quarters, then eighths, and so on, always cutting through the center. So below is an example of cuts made by chef in sequential order. So as you can see, when it was an entire circle, he simply cut it into halves. Then he cut it into quarters, then into eighths, then into tenths, and so on, as you can look. So one thing that you will all be observing is what he is always doing is, if let's suppose if you observe in this figure, let's draw it. Let's suppose he have this circle for now. Okay. And now these 4 are equal parts. Okay. Now what he does is he makes one more cut. Okay. And now he is having these 2 bigger parts and these 4 smaller parts. If you look, he is having 2 bigger parts and 4 smaller parts. Now, the next cut that he is making is cutting the bigger parts and not the smaller parts. If you look, he is not doing something like this. This is not happening, that you have the circle something like this 4 are smaller parts, and now you are cutting something like this. This is not happening in the next step. The thing that is happening in the next step is that you have the bigger parts and now you are cutting the bigger parts into smaller ones. So what you are doing? You have these smaller parts, you have 2 bigger parts, and now you are cutting the bigger parts into the smaller ones. Okay. So if you observe that this is always the pattern followed while cutting, like if you observe once in the step 4, you have now 8 equal parts. After that, he made a cut. And now he is making the cut to all the bigger parts in the further steps. So every time what you will be given is you will be given some X, that is he had made X slices. X is always even. So your task is to determine that how many number of pieces will be smaller than the rest. Like for example, if you look up to this, over here you have 6 parts. So the value of X is 6. So the answer to this part will be 4 because there are 4 parts that are smaller than the rest, because we have 2 bigger parts and 4 equal smaller parts. So there are 4 parts that are smaller than the rest. So the answer for this part will be 4. Similarly, if you look up to this figure in which we have 4 slices, that is the value of X is equal to 4. So in this case, the answer will be 0. Why? Because there are no such parts which is smaller than the rest, isn't it? So yeah, so answer to this part will be 0. Is this clear till now? Till now, any doubt? Anyone? Any doubt, guys? No. Great. Now let's see how we can do this then. Yeah. So let's see how we can do this. So if there was a quick observation, if you observe that if we have slices in power of 2, if we have something like this, that if we have 2 power 0, that is only 1 slice. If we have 2 slice, that is 2 power 1. If we have 4 slices, that is 2 power 2. If we have 8 slices, if we have something like this, that is 2 power 3 slices, to all these, the answer will always be 0, isn't it? That is how I thought in the contest, that, okay, looking up to the all the slices of the power of 2, the answer to all of them will always be 0, isn't it? Now, if you observe something, some slices that are not of power of 2, so what you are basically doing? Let's assume by taking the example of this slice. Okay, you have 4 slices. Now you made a cut. once you make a cut, what will happen? If you observe, whenever you are making a cut, it is cutting two slices. This is one of the slice that it cut, and this is the other slice. And it cut the slices into two equal parts. It cut the slices into two equal parts. So can I say that two bigger slices were converted to four smaller slices? Can I say this? That two bigger slices were changed to four smaller slices. So can I say that every cut increases the number of slices by two? Just observe one thing. There were two bigger slices. I increased them to four slices, four smaller slices. So how many slices actually changed? Earlier you were having two, now you have four. Yeah, the dimensions vary, but the count of number of slices only increased by two. So one thing that I observed is that when I increase the size of the number of slices by two, if I increase the number of slices by two, the count of, that is the number of smaller slices, increases by 4. All good till here? If I am increasing the number of slices by 2, my count of the number of smaller slices increases by 4. Is everyone able to relate this? Yeah. So can I say that, okay, till if the number of slices I have are 4, the answer is 0. If the number of slices I have is 6, that is the value of x. If the value of x is 6, my answer will be 4. If the number of slices by 8, my answer should have been 8, but you observe that the number of slices are also 8, and the number of smaller slices are also 8. So we can say that answer for this part is 0, and we even discussed that if number of slices are of power of 2, so for them the answer will always be 0. Again, if the value of x is 10, so it will increase by 4, so it will become 4. If the number of slices are 12, so it will again increase by 4, so the number of smaller slices will become 8. Again, if we have number of slices as 14, that is the number of slices increased by 2, so the number of smaller slices will increase by 4, so it becomes 12. Now, again, if number of slices becomes 16, increases by 2, so the number of smaller slices will increase by 4, so it should have been 16, but the number of slices are also 16 and number of smaller slices are also 16. So we can say that, okay, all slices are of equal length, or sorry, of equal dimensions, and so the answer will be 0. And as already discussed, if there is any slice that is of order of, that is of power of 2, so for them the answer will always be 0. And this was the pattern followed. So from here for 18, you can say that the number of smaller slices are 4, for 20 it is 8, for 22 it is 12, and so on. Similarly, from reaching till 30, once you reach 30, you will say that, okay, you have like for 24, let me do this. Yeah. So if you just go on for 30, you can say that answer will be 28. And for 32, you will say the answer will be 32, but 32 is not possible because like 32 smaller slices, 32 total number of slices. This makes the number of smaller slices actually 0. So this is actually the logic behind this question. Should we move on to code? Anyone, any doubt? Yeah. So let's see the code. So what actually the code is? The code should say that if my x is of power of 2, so my answer should be 0. So I simply check the number of set bits in x. If it is 1, this means that x is of power of 2, isn't it? So in that case, I am simply printing 0 and I am returning. But if it is not so, so what I actually want, if you all think what I actually want, if I know that, okay, I want for x equals to 12, what will be my answer if I want to know this? So can anyone guess how can we get answer for x equals to 12? If we want answer for x equals to 12, how we can get it? So what we can actually do is, if we know that for x equals to 8, the answer is 0. From where is this 8 coming? This 8 is actually the largest number which is smaller than 12 and is a power of 2, isn't it? The largest number that is power of 2 that is less than x is actually 8. So at 8, we know that answer is 0. At 10, we know the answer will be 4. And at 12, we know the answer will be 8. So actually, our answer will be, if we are able to find such number 8, if we are able to find number 8, that is the largest number that is less than 12 and is a power of 2, if we are able to get that, so our answer will be just 12 minus 8 multiplied by 2, if you observe. Because for 10, it is 4. Every time we are increasing the number of slices by 2, the number of smaller elements increases by 4. So there is an extra increase of 2. So that's why we multiplied by 2. Difference multiplied by 2. So our aim is to get this number 8. How we can get this? For 12, if you try to write down the binary representation of 12, so it would be something like this. It would be something like this. This is actually what 12 is. So the smallest number, which is the largest number that is power of 2 and is less than 12 is actually this. That is the most significant bit and all zeros. Because we know that any number is a power of 2, so then it will contain only like one set bit, right? And all other bits will be 0 moving forward. So the largest number that is smaller than this particular number and is a power of 2 is actually the number formed by taking the most significant bit as the set bit. So actually we want this number. If we are able to find this number, then we will simply subtract it from this and multiply 2 and get the result. So this number can be easily found. How? If we just find out that what is the position, that if we have this number and we want to reach till here, so we can simply find out that, okay, what is the bit position of this particular bit? And we can simply do something like this, one left shift bit and get this number. We know that this is the third bit, isn't it? This is the third bit. So one left shift 3 will actually give us this number 8. So how to get that this is the third bit? So just count the total number of zeros that is present before this one. So total number of zeros that are present before this one, if you are able to find this and just subtract 31 and just subtract it from 31, so you will get the bit position of this particular bit. Like for example, if you look, we have 28 zeros before this, right? Isn't it? Because we know that every number can be represented in 32-bit form. So we know that there will be, if there are 4 bits over here, then there will be 28 bits present before. So we can say that, okay, if we know that this number is 28, that is 28 trailing leading zeros are actually present. These are called as leading zeros. So if we know that 28 leading zeros are actually present, so we can simply do 31 minus 28 and get the bit position of this particular bit. So that's what I did, because we know that we have a function to count the number of leading zeros. So the index for this particular bit, the most significant bit, will be 31 minus built-in count leading zeros of x. And then we simply found out temp, that is that number 8, because we know that index is 3, but we need to get the number. So that number is one left shift index. And once we have that, we can simply print x minus temp multiplied by 2. There may be multiple ways by which you do this. This is actually a simple implementation, but the main logic was something that we already discussed, that whenever we are increasing the number of slices by 2, the number of smaller slices increases by 4. That was the main logic, and implementation, it all depends on you, how you write it. This is actually the way I do it. Is the logic clear for the first question? Anyone, any doubt? Anyone? Just let me know if any doubt persists. Yeah, it actually counts the number of leading zeros. It actually counts the number of leading zeros. So if you have the number something like this, yeah. So we know that every integer can be represented in 32 bits form, right? So if we have a number something like this, 1100, so you know that there will be like 28 leading zeros present before. Yeah, actually, the thing is that if you have Is this thing clear that if we have number something like this, then our aim is to get number something like this, so that if this is x and this is y, so we can do, our answer will be x minus y multiplied by 2. Is this part clear? Is this part clear? That our aim is to get this particular number? Because we, yeah. So if we are able to get this particular number, so the things will be done. So how to get this particular number? This particular number is actually, if you look up to this x, so the most significant bit of this x is the only set number in this y. So if you get the index of this particular bit, this is index 0, 1, 2, 3. So if you get the index of this particular bit, so the things will be done, right? So that is how I wrote that. Okay, if I know that every number have 32 bits. And I also know that how many leading zeros are present in this number. If I know this, so I simply subtract it from 31 because the bit positions are 0 to 31 and get the index of this particular bit. This was the thing. That I know that, okay, 1100 is there. There will be 28 zeros. So 28 zeros in the leading zeros, because we know that every number have 32 bits, right? So we simply did 31 minus 28 and got the index of this particular bit. Once we have that, so we can get that number by doing 1 left shift IDX. We can get this number. Okay. So let's move on to the next question. Wait a minute. Yeah. So the question was array removal. Let's go through the problem statement. You are given an array A of size n. Your task is to determine the minimum number of elements that need to be removed from A such that the bitwise OR of the remaining element is 2 power x minus 1 for some integers x. Note that the bitwise OR of an empty array is considered to be 0. Okay. So what is the question? The question is that there are n numbers. So you have n numbers. There are n numbers. Okay. Now the question is that you are doing OR of all these numbers. You are performing an OR operation. I hope everyone is familiar with OR operation. Okay. Anyone who is not familiar with OR operation? I hope so. No. Yeah. So once you have, you know, you are doing the OR of all the numbers. Now what you want is that once you do all OR of all the numbers that are present in the array, the result should be of the form 2 power x minus 1. So can anyone guess that how 2 power x minus 1 looks? For any x greater than equals to 0, how 2 power x minus 1 looks? Yeah, it is all ones. 2 power x minus 1 is actually x ones. Yeah, last x bit sets. And like you don't have any other bit set. Like this is how 2 power x minus 1 looks. Okay. So the question is that you will remove some elements from this array, because it may be that if you are not removing any element, you get result something like this of OR. It is possible that you are getting the OR result something like this. So you don't want this thing to happen, isn't it? You want a result something like this, so that last all bits are set and no other bits are set. So you have to remove some numbers from the array. Okay. Once you do so, you want this particular result. Now the question is that what is the minimum number of numbers that you will remove? What is the minimum number of numbers that you should remove so that you are able to get some result something like this? Is the question part clear? Yeah. So how we can get this? So what actually I thought during the contest was that, okay, we know that looking to the constraints, if I go to the constraint, wait a minute. Yeah. So we have all AIs in the range of 0 to 10 power 9, isn't it? So what actually we will have? We will have at most 32 bits in the number, isn't it? So what are the possible results I can get? One possible result is at the end, that after removing the numbers. Okay. One possible result that I can get is 1, 1, 1 up to 31 times. Next is 1, 1, 1, 1, 1 up to 30 times. Next is 1, 1. Wait a minute. Yeah. 1, 1, 1, 1, 1 up to 29 times, and so on up till 0 times. These are only 32 possible combinations I can get. Do everyone agree with me? These are only 32 possible combinations that we can get at the end. There are no other possible combinations. Do everyone agree?
Yes.
Yeah. So what I thought was that, okay, explore all the combinations. Explore all combinations. By that, what I mean is, if let's suppose I say you that I want the final result to be this. There are 4 ones at the end. I want this. So can I say one thing? That all the numbers that are greater than this particular number can't be included. Can I say this? That all numbers, this is actually 15. Okay, so all numbers greater than 15 can't be taken. Can I say this? Because if I take the number greater than 15 and I do OR with this particular number, I will get a result that is greater than this value, isn't it? And for now, I am only exploring this possible option that, okay, can I get something like this? That what are the number of elements I need to remove to get this particular result? So is this, can I say that all the numbers that are greater than 15 can't be taken? Isn't it? Now, so that only I did that, okay, explore all situations. Exclude elements greater than the situation. And even if you are including it, even if I, let's suppose, say that one of the possible numbers is 1011, one of the possible number is 1001, and the other number is 0010. Okay, these are the 3 numbers you have, and you are seeing that, okay, this possible combination is this is a possible combination or not. Let me write it to other page. You have 1011, you have 1001, and you have 0010, let's suppose. Okay, these are the 3 numbers you have, and you are checking that, okay, this combination is possible or not. So what you do? You go to this particular number. Is this particular number greater than this? The answer is no. So you will take this. Again, this possible number is greater than this? No. Again, you will take this. This possible number greater than this? No. Again, you will take this. But just say me, if I OR these 3 elements, I will get this as my result. Is this equal to this?
No.
No. So can I say that this particular combination can't be formed? Can I say this?
Yes.
So I can simply say that, okay, this possible combination can't be formed. So yeah, that is actually the method to solve this question, that explore all the possible situation. Just take the elements that are lesser than or equal to this particular element, take their odds, and if you are getting an OR equal to this, you can say that, okay, in that just simply you have kept a count that, okay, how many numbers you were removing. And if this particular combination is not possible, in that case, you can say that, okay, this particular combination is not possible. Let's move on to some other combination. So in this case, you can say that, okay, you are removing all the elements, that is n. That is the maximum possible value also. Because if you are removing all the elements, the odd is 0, which is also an answer, which is also a possible answer. Because you are said that, okay, the odd of, because you are said that the value of x is greater than equals to 0. So if you take x equals to 0, so it's actually 2 power 0 minus 1, which is equals to 0. So even if you are removing all the elements, there is an answer possible. But your task was to minimize the number of elements to remove. So that's how you will do. That is the logic to this question, that explore all the possible combinations. And in that, you see that how many elements you need to remove. And even after removing, you are getting that possible combination or not. So should we move on to the code? Any doubt? Let's understand the code and then we can take the doubts. Okay. Yeah. Wait a minute. Yeah. So first of all, it's actually a template. It's not extra code. This is actually a template that I use. That's nothing to bother. First of all, took the number of test cases. No, not necessary. Took the number of test cases and for every test case called this solve function. Okay. This is a common practice. Now what we are doing? First of all, took the inputs of number of numbers and the inputs of vector. Then initialized our answer to n because this is a maximum possible answer, isn't it? This is the maximum possible answer. That is, we are removing all the elements of the array. Now went to all the possible combinations. So started from I equals to 0, I less than 32, I plus plus. For any I, what is the value that we are looking? 1 left shift I minus 1, isn't it? Like for I equals to 0, you will look for I equals to 0, you will look for 0. For I equals to 1, you will look for 1. For I equals to 2, you will look for something like this. For I equals to 3, you will look for something like this. For I equals to 4, you will look for something like this, something like this. So we are doing all the possible combinations. So this is actually 2 power 2 minus 1. This is actually 2 power 3 minus 1. This is actually 2 power 4 minus 1. So for any I, the value that we are looking is 2 power I minus 1. Okay. So yeah, this is the val. Now just kept one temp variable which is initialized to 0. In this we will keep the result of OR of all the elements that we are taking, and initialized our f equals to 0, which implies the number of numbers that we are taking. Now went to each of the numbers. If a particular number is greater than the value that we are looking for, so we know that we can't take this number. So in that case, simply continue. Otherwise, we are taking that number, that is increasing the count of f. And since we are taking that number, we are doing an OR operation of it. So in our temp, we will store temp or equals that particular number. At the end, if temp is equals to val, so we know that since we have taken f numbers, so the number of numbers that we have removed is actually n minus f. Since we have taken f numbers, so the number of numbers that we are removing is n minus f. So we can just say answer as mean of answer comma result. We can just do this for every possible combination, and at the end we can print our answer. So yeah, that's the code for this question. Is this clear? Yeah. The thing is that you need to look for all possible combinations. So if I am at a combination that if I am at if I am at something like this, let's suppose I am at something like this. Okay, this is the number that I am looking for. All others are 0. So if I get any number something like this, which is greater than the value that I am looking for, should I include this number? The answer is no, right? I should not include this number because if I do so, the OR result will definitely not result to this. It's not possible. So I can't include this particular number. So I am just excluding all the numbers that are greater than the value that I am looking for. Else, I am taking that number. If I get something like this, if I get something like this, I am taking that number. All the numbers that are less than equals to this particular value, I am taking those numbers. And since I am taking this, so I know that at the end what I am doing, the numbers that I am taking, I am doing their OR, isn't it? So I am just storing their ORs. So initialized my OR result to 0. And just since I am taking this number, I am doing an OR of this with all the other numbers that I have taken, isn't it? Once I have these, so I am just checking at the end if the OR result that we got is equal to the combination that we were looking for. If it is so, we know that, okay, n minus f are the number of numbers that we have removed. So the answer will be minimum of answer comma result. And in our result, what is stored? N minus f. So yeah, this was the solution. Yeah, there may be like many ways, but this was the way that I thought during the contest. Like, yeah, so that all possible combinations are explored. Okay, any doubt in this solution? Because there are only 32 possible combinations now. You can have either 0, 0, ones at the end. That is the number is 0. You can have 1, 1. You can have 2 ones. You can have 3 ones. You can have 4 ones. You can have 5 ones. You can have 6 ones. You can have 7 ones. Something like this. Because these are the numbers of the form 2 power x minus 1, right? There are only, because there are only 32 bits, no? So at max, what you will get? 31 ones. So 0 ones, 1 ones, 2 ones, 3 ones, so on up till 31 ones. That's why the loop of 32. Yeah. Okay. So let's move on to the next question. Yeah. This was actually a more easy one as compared to the previous one. Number hunt. So let's go to the problem statement. Given a positive integer x, find the smallest positive integer y, satisfying all the following conditions. First, y should not be a prime number. Okay. Second, y should not be a perfect square number. Third, no factor of y other than 1 is lesser than x. Okay. So these are the 3 conditions that you need to satisfy. So what's the question? The question is that you have a number x, you need to look for number y, and there are 3 conditions. The first condition is that this number y can't be prime. This number y can't be a perfect square number. And it cannot contain any factors that are lesser than x. Okay. So I need to look for the smallest y that satisfies this and just need to print that y. So that's the question. So how we can do this? How to think of this question? So if you think a bit that, okay, we are taking a number y. If we take a number y, something like anything which is not a prime number, I am taking y as not a prime number. Okay, I take because it is mentioned that y can't be prime. So let's suppose x was 16 and I think of taking y as 20. So it is possible that when I prime factorize this y, I can get a factor that is lesser than x. But if that happens, so can I say that this condition that no factor other than 1 should be lesser than x will be exploited? Can I say this? So from here, what I think is that, okay, whatever factors this number y contains, it will contain factors because we are said that this is not a prime number. So whatever prime factors this number y contain, that prime factor should be greater than equals to x. If that is possible, I can say that any factor is not present in y that is lesser than x. Because we know that prime factors can't be broken down further. Prime factors are like the smallest bit factors that are possible. Like if for 20, 10 is a factor, and you can simply break down 10 also. You can say that, okay, 5 is also a factor of 20, but you can't break 5. So prime factors are the smallest factors for any number. Like they can't be broken down further. We can say this, isn't it? So if we just think that, okay, if we think of constructing y via prime factors that are greater than equals to x, so we can definitely say that, okay, it's not possible that y contains any factor that is lesser than x. Is this point clear? If we are constructing y with prime factors greater than equals to x, then we can say that our conditions are satisfied. Do anyone have any doubt till now in this point? Anyone? No. Great. Now, okay. So what we know that, okay, we need to look for prime numbers greater than x. So should we take 3 prime numbers? Should we form y something like this, p1 multiplied by p2 multiplied by p3, where pi is greater than equals to x and pi is a prime number. Should we do something like this? Should we do something like this? We should not do. Why? Because we want our y to be minimum. So even if we take only two prime numbers, p1 and p2, and simply multiply them, and I know that since p1 is also greater than equals to x and p2 is also greater than equals to x, so my y will definitely be greater than x. Why should I multiply another prime factor and make this y more larger? I want to find a minimum y. So the question simply comes down to just look for two smallest prime numbers, two smallest distinct prime numbers. Now again, why distinct? I will come to that. Two smallest distinct prime numbers that are greater than x. If I'm able to find that, let's suppose they are p1 and p2, so my answer will be simply p1 multiplied by p2. And why distinct? Because I am also said that the number should not be a perfect square. So if let's suppose I say that, okay, p1 is smaller than p2, then why I am multiplying p2 to p1 instead of doing something like this? Why I am not doing something like this instead of, why I am doing something like this, p1 cross p2, where p2 is greater than p1? And why not this? This will result into more minimum y, no? Then why I am doing something like this? This is because of one condition, that y should not be a perfect square. If I do this one, p1 multiplied by p1, then the resulting y will be a perfect square of p1, isn't it? So that's the reason I just need to look for two distinct prime factors greater than equals to x, and just simply multiply them and get the result. So it's a simple brute forcing technique. Just simply go from x, look for two prime factors, multiply them and get the result. Is this okay? There is no need times, because it's given that x is like 10 power 9. X is up to 10 power 9. So you can't pre-compute primes greater than like 10 power 9. How will you do that? Isn't it? Yeah. So let's move on to the code. It's a pretty simple implementation. How to check that whether a number is prime or not? How we can check? Just see the number of factors it has. If it has any factor other than 1 and the number itself, then it is not a prime, isn't it? So let's see. Yeah. So we took the input of x, initialized our count to 0. That is, I need to look for two prime numbers, isn't it? So those two prime numbers will be num1 and num2. And the prime number should be greater than equals to x, isn't it? So I simply started from I equals to x. Just wrote two conditions for x equals to 1 and x equals to 2, though not necessary, but I wrote this during the contest. Now, while the number of prime numbers that I got is still less than 2, I need to look for prime numbers, isn't it? The prime numbers starting from I equals to x, starting from I. That is, all the prime numbers that I am looking for should be greater than equals to x, isn't it? That is why I am looking for the search of prime numbers from I equals to x. Now, initialized my f to 0. That is, I am getting a factor or not other than 1. So this is a simple for loop for checking all the factors of I. All the possible factors we know that always will lie from 1 to square root of I, isn't it? So like from that we can get. So starting from j equals to 2, j into j less than equals to I, j plus plus. If I modulo j is equals to 0, we are looking for the factors of number I. So if I modulo j is equals to 0, this means that we have a factor other than 1 and the number itself. This means that this number I is not a prime number. So simply marked f as 1 and break from it. If after coming out of this while loop, my f is still 0, what does this implies? This implies that the value of I, the I is a prime number, isn't it? So if I is a prime number, if my count is 0, that is I have not got a prime number till now. So initialized my num1 to I. If my count was not 0, then it would be 1. So in that case, initializing my num2 with I and simply incrementing my count. And I'm doing this till my count is less than 2. That is, I have not got two prime numbers. And after all these, I'm simply incrementing my I. That is just checking for the next number. So what I am simply doing is, I am simply starting from x. I have initialized my I to x, checking that this is a prime number or not. Then checking if x plus 1 is a prime number or not, x plus 2 is a prime number or not, x plus 3 is a prime number or not. Until when I am doing this, till I get two prime numbers. Once I get two prime numbers, my search is over. I need to simply multiply them and output the result. Okay. So this was like a simple implementation of this particular question. Till here, is it clear to everyone? Anyone having any doubt? So yeah, let's move on to the last question for today. The fourth one. Yeah, this was like a quite interesting one. Let's read the question first. How many were able to solve this? If you actually look to the code of this question, just a brief, this is actually the code. But there is a logic behind it. Yeah, we will discuss everything, Naveen. Not a problem. So let's go through the question once. The question name is sum of XORs. You are given a grid of size n cross m where n and m are both even. An important term to notice that n and m are both even, where each cell of the grid has value 0. Okay. Now let Ri denote the bitwise XOR of all the elements of the ith row, and Ci denote the bitwise XOR of all the elements of the ith column. So ugliness of the grid is defined as summation of I equals to 1 to n Ri plus summation I equals to 1 to m Ci. So what actually ugliness is saying is that if you have a grid of size n cross m, so what you do, you calculate XOR of the first row. Let's suppose you say it as R0. You calculate XOR of second row, say it as R1. XOR of elements in the third row, say it as R2, and so on up till Rn. Okay. Similarly, you have m columns. So for first column, you calculate the XOR of all the elements in the first column, say it as C0. Calculate the XOR of all the elements in the second column, say it as C1. Similarly, up till m columns you have, so Cm. So your ugliness value is R0 plus R1 plus R2 plus dot dot up till Rn minus 1 plus C0 plus C1 plus C2 up till Cm minus 1. This is actually what your ugliness value is. Now, in the question, they have told that initially all the values in this grid are 0. And what you're doing is you have defined a function f of k. In this f of k, what you are actually doing is you are filling exactly k cells of the grid with 1. Let's suppose I want f of 1. Let's suppose I'm looking for f of 1. So f of 1 actually tells that you have the grid. And what you are doing, you are filling only one cell of it. That is k number of cells. Over here, the value of k is 1. So you are filling one cell with 1. Okay. So that is actually what f of k is. So f of k is actually, if you are filling k cells with 1, then what is the minimum possible value of this ugliness? So f of k denote the minimum ugliness possible after setting the value of exactly k cells of the grid as 1. So your question is that if you are setting one cell, two cells, three cells, up to, there are total number of n multiplied by m cells in this grid, isn't it? If there are n rows, m columns, so there are n multiplied by m cells. So if you're setting one cell as 1, if you're setting two cell as 1, if you're setting three cell as 1, up till n multiplied by m cell as 1. So in all those, what was the ugliness value that you got? You need to simply sum up those and just output the answer. So that's the question for you all. Is the question part clear? So let's see how we can solve this. So the first thing that you can think is this is that, okay, we are told that n is also even and m is also even. So there must be some significance of this now. Otherwise, they would have not told us. There must be some significance of this. So what if you look is, do everyone know that if we do XOR of even number of ones, so the result will always be 0. Do everyone know this? Yeah. So can I think that, okay, if I have k modulo 4 equals 0, if I have something like this, that, okay, the number of ones, that is the number of ones that I am putting in this grid, gets divided by 4. That is k modulo 4 is equals to 0, is a multiple of 4. K is actually a multiple of 4. If that is the case, can I say that I can always select a 2 cross 2 grid and make all these values as 1? I can always select 2 cross 2 grid and make this value as 1. I can always select 2 cross 2 grid and make this value as 1. And if I am doing so, if you look, if I am doing so, if you observe one thing, if I am doing so, my XOR result will always be, my ugliness result will always be 0. Because if you take the XOR in this row, in this row, in this row, in this row, it will come out to be 0. In this column, in this column, in this column, in any column you take the XOR result, it will come out to be 0. So I can say that if k is multiple of 4, my answer is 0. Not answer, I would say my ugliness. Ugliness will always be 0. Do everyone able to relate with this? That if k is a multiple of 4, the ugliness value will always be 0. Now, what if it is not a multiple of 4? What if it is of the form, let's suppose k plus 1, some n into, let's suppose 4 into c plus 1. If k is of form this, that on dividing by 4, it's giving 1. What if it is something of form this? Give me a minute. Yeah. So if this is the case, can I say that, okay, I can always fill a grid till 4c, like k is of form 4c plus 1, that is on getting divided by 4, it gives me remainder 1. So I can say that I can always fill in the order of 2 cross 2 grid. Yeah, I can always fill in the order of 2 cross 2 grid. And now for one extra grid, for one extra cell, I will fill that cell with any one cell, and the result will always be 2. If you observe, for this particular row, the raw result is 1. And for this particular row, and for this particular column, the raw result is 1. So only in these two only these two values will get added, 1 plus 1, that is equals to 2. And it's not possible to minimize this 2. Your aim is to minimize the ugliness value, but it's not possible if k on dividing with 4 gives a remainder 1. So you can say that always your answer will be 2. Your ugliness value will be 2. Okay. Similarly, if k on getting divided by 4 gives me 3, if k on dividing by 4 gives me 3, so again I would say that ugliness value will be 2. Why? Because this is the case when k on dividing by 3 gives me, k on dividing by 4 gives me 3. This is the case. So if you look, 2 cross 4 if we take, yeah. So if we first of all, let's suppose k was 7, or k was, let's suppose k was 7. This on dividing by 4 gives me 3. So you fill this 4, and now you will fill 3 more cells. So you will fill any 3. If you fill any 3, you will always observe that the value of XOR is again 2. Ugliness value is again 2. Because for this particular column, the XOR result is 1. And for this particular row, the XOR result is 1. And for this particular column, the XOR result is 1. And for all other rows and columns, the raw result is 0. So the total ugliness value for this particular configuration will be 2 again. And there is no other possible combinations that you can make. So I can say that if, so what I got till now I am able to conclude that if k modulo 4 is equals to 0, my ugliness value is 0. Else, if k modulo 4 is equals to 1 or k modulo 4 is equals to 3, so my XOR result, my ugliness value is 2. Now the only case left is k modulo 4 is equals to 2. Till here, till k modulo 4 equals to 0, 1 and 3, is everyone able to relate? Anyone having any doubt till now? Anyone? Any doubt till now that for k modulo 4, the answer will always be 0. For k modulo 1, it will always be for k modulo 4 equals to 1, the answer will always be 2. And similarly for k modulo 4 equals to 3. For every addition of 1, 0 adds by 2 and after 4, it's the 0, 0. Why this won't work? No, like what you want to say, for every addition of 1, the XOR adds by 2. How? I have already proved that for 3, the XOR result is always 2, isn't it? Because whenever you are adding it, whenever you add 2 ones to the same row, if let's suppose initially it contained even number of ones, so now again it will contain even number of ones, no? So answer will not get increased actually, it will get decreased. So always it's possible. Yeah. Now the thing is, no, this does not repeats actually. This does not repeats. This case that k modulo 4 equals to 2 is a bit tricky. Let's see how. Okay. So when you think k modulo 4 equals to 2, what generally comes to our mind? That, okay, take k as 2 and see what is the result, isn't it? This is what comes to our mind generally. So if k is equal to 2, what is the XOR result? Whatever is the greed, I don't really care. Whatever is the greed. Can I say if the value of k equals to 2, the minimum possible XOR that I can obtain is actually 2? Can anyone over here obtain a lesser XOR than 2 if the value of k is 2? Isn't it? Yeah. For 2, it's always 1. Similarly, if I say that, okay, the value of n is, let's suppose, 4, and my value of m is also equals to, let's suppose, 4. Okay. My value of n is 4. Let's suppose first take one case this, that my value of n is 2 and whatever is my value of m, I does not care. So what I say is that let's suppose this is number of columns. I have 2 columns and I does not care how many number of rows I have. In this, if we are having k modulo 2 equals to 0, what will always the XOR value be? If we are having k modulo 2 equals to 0, we will fill something like this, that this is for k equals to 2, isn't it? For k equals to 2, we got XOR value as 2. For k equals to 6, again we get XOR value as 2. We have this one more over here. Let's extend it over here. Yeah. For k equals to 10, or I would say, yeah, 10, you will again get XOR value as 2. So whatever you are doing, whatever k modulo 2, k modulo 4 equals to 0 you are doing, k modulo 4 equals to 2 you are doing, in that always you will get XOR equals to 2. It's not possible to get a lesser XOR. Just try to imagine however you fill, whatever way you fill, it is actually an observation. In whatever way you fill, you can write it. That if you have, let's suppose something like this. So again, in any order you fill, if I say you that you have to fill k equals to 2, you have to fill 2 ones. So you can see that the minimum XOR that you can get is 2. Again, if I say you that you have to fill with k equals to 6, that is you need to fill 6 once. So again, the minimum XOR, when whatever combination you fill, the minimum XOR that you can obtain is again like 2. So I can say if any of n or m is equals to 2, so for every k modulo 4 equals to 2 as well, my XOR result will always be 2. Can I say this? If any of n or m is equals to 2, so for any k modulo 4 equals to 2, my XOR result will always be 2. Can I say this? It's not possible to obtain a lesser XOR result. But the things get interesting when both n comma m is greater than 2. Let's suppose both n and m are equals to 4. Let's solve for this case and see how the things change. 1, 2, 3, 4, 6. Yeah. Now in this, now again, if I in this I am filling 2 ones. Okay. So again the XOR result will be, my ugliness value will be 2 only. There will not be a change. Again, if in this I am filling, let's suppose 4 into 4 minus 2 ones, that is 14 ones. If I am doing so, so what actually happens is that I have all the gray cells filled with 1. And in this I need to remove 2 ones, isn't it? This is actually when I am filling 4 in cross 4 minus 2 ones. So whatever 2 ones I remove, my XOR result will again come out to be 2. My XOR result, the ugliness value, I have said multiple times XOR result, but that actually the ugliness value, my ugliness value will again come out to be 2. It's not possible to minimize it. But if this is not the case, if k is other than those two values, that is 2 and n cross m minus 2. If k is other than these two values and k modulo 4 is equals to 2, it's possible to obtain the XOR value equals to 0. It's possible, yeah. Let's see one example. You can form these, like the value of n and m in over here is 4, and I'm taking the value of k as 6. So see, if I do something like this, this contained even, and now this. Yeah. Now see, I have filled 6 once, and all the rows and all the columns have XOR value 0, and hence the ugliness value for k equals to 6 is 0. This is also possible for 10. It's also possible for, it is possible for k equals to 6, it is possible for k equals to 10, and it is possible for any k modulo 4 equals to 2 if the value of k is not equals to 2 and the value of k is not equals to n cross m minus 2. So yeah, that was actually the logic behind this question, that if any of n or m is equals to 2, in that case, only for k modulo 4 equals to 0, we are getting the ugliness value as 0. And for all other k modulo 4 equals to 1 or 2 or 3, we are always getting the ugliness value as 2. So we can say that if any of n or m is equals to 2, my answer will be 3 by 4th of nm. Because we know that since n is also even, m is also even. So n cross m will be like n multiplied by m will be divisible by 4, right? So 1/4 of it is equals to 0 and rest all are equals to 2. So my answer will be 3 by 4 of n cross m multiplied by 2. If any of n or m is equals to 2. But if this is not the case, so what I know that if both n comma m are greater than equals to 4, so my answer will be, I know that for k modulo 1, I will always, k modulo 4 equals to 1, I will always get my ugliness value as 2. For k modulo 4 equals to 3, I will always get my ugliness value as 2. So these two are sorted. So like 2 by 4 of nm. And I know that for k modulo 4 equals to 0, my ugliness value will always be 0. And for k modulo 4 equals to 2, there are only two cases when my ugliness value will be 2 and rest all the times my ugliness value will be 0. So in this case, my answer will be 2 by 4 multiplied by nm multiplied by 2. That is because the XOR value is 2 plus 2 plus 2. That is plus 4. So actually my answer will be nm. If you calculate this, it will be nm plus 4. So if any of n comma m is greater than equals to 4, so my answer will be nm plus 4. Else my answer will be, if you look, 3 by 2 of nm. So that is actually the code for this solution as well. That if either of n or m is equals to 2, so my answer will be 3 nm by 2. Else my answer will be nm plus 4. Is the logic understood? Like, it was a decent question. It was very tough to think. Do everyone get this? Yeah, that is like, yeah. Uh, the formula again means, should I explain the formula again? Why nm plus 4? Okay, see. Wait a minute. Yeah, so you know that for k modulo 4, your answer is always 0. For k modulo 4 equals to 0, the ugliness value is always 0. For k modulo 4 equals to 1, the ugliness value is always 2. For k modulo 4 equals to 3, the ugliness value is always 2. And for k modulo 4 equals to 2, there are only two cases when the ugliness value is 2 and rest all the cases it is 0. So for k modulo 4 equals to 2, your answer will get added by 4. That is, there are only two cases when ugliness value was 2, isn't it? So this occurs n cross m by 4 times. This again occurs n cross m by 4 times. This again occurs n cross m by 4 times. And this again occurs n cross m by 4 times. So now if you just simply add, nm by 4 multiplied by 2 is nm by 2 plus nm by 4 multiplied by 2 is nm by 2 plus 4. So it's actually nm plus. So anyone else having any doubt in any of the questions we discussed? Let me stop the recording.